This example will show you how to use the Utilities feature in ASPEN Plus to simulate the utilities requirements for each equipment that requires duty or power. To demonstrate how the utility features in ASPEN Plus work, we need a converged flowsheet simulation to perform this task. Here, we will use the successfully converged flowsheet simulation of the ammonia production process from exercise 3. From this PFD, you can see that there are several pieces of equipment that require duty and power. There are heater B3 that requires heating duty, cooler B5 which requires cooling duty, and two compressors B1 and B8 which require power. Let's assume that there are three types of utilities available in the plant as follows: gas for heating utilities, cooling water for cooling utilities, and electricity. In this table, there will be the information of each utility types regarding the energy price, heating and cooling value, inlet and outlet temperature, and the assigned blocks. For gas, the energy price will be $4 per MMBTU. The heating and cooling value will be 23,903 BTU per pound. And also the gas should be assigned to the block heater. For cooling water, the energy price will be $0.6 per MMBTU, with the cooling value 45 BTU per pound, and the inlet and outlet temperature will be 75 and 120 Fahrenheit. And the cooling water should be assigned to the cooler block. The last one is the electricity, which has the energy price at 5 cents per kilowatt hour. And the electricity should be assigned to both of the compressors. So, your tasks are to create the utilities and fill out the utility data, and also you need to assign the utilities to the blocks that require duty or power. Let's return to the ASPEN Plus with the converged flowsheet simulation from exercise 3. So the first task here is to make sure that the flowsheet is fully converged. So try to click the Run button to check that the simulation is converged successfully. The status shows results available without any error appear, meaning that the flowsheet was converged successfully. After that, we will do the task to create the utilities. In the simulation environment, go to Utilities folder. In the Utilities window, click New. Enter the utility names as gas, and in the copy form, please select blank. Click OK. This sheet is the specification sheet where you need to input all the utilities information. Choose the utility types as gas. In the utility cost, select energy price and enter $4 per MMBTU. Under the heating and cooling values, fill the heating and cooling values as 23,903 BTU per pound. So that's all for the gas utilities. We already put all information of the gas. The next one is to add the utilities of cooling water. Go back to the Utilities folder, click New. Create a new utility as water, and in the copy form field, please select cooling water and then click OK. If this window appears, click No. In the specifications sheet, please complete all the information of the cooling water. The first one is the energy price, which is 0.6 US dollar per MMBTU. Under heating and cooling values, select Specify heating and cooling values. Fill out 45 BTU per pound of the cooling values. The inlet temperature as 75 Fahrenheit and outlet temperature as 120 Fahrenheit. And the other information you should leave it as default. The next one is to create the electricity utilities. Go back to the utility folder again, click New. Create a new utilities as Elect. And in the copy form, please select the electricity and then click OK. Here, in the utility cost, put the purchase price as 0.05 US dollar per kilowatt hour. So now we have complete adding all utilities in the process. The next task is to assign the utilities to the blocks. Please go to the block B3, which is the heater. Then go to the Utility tab. Here, you should select the utility as gas. The next one is to assigning the duty for cooler, which is the block B5. Go to block B5 in the input sheet. Go to Utilities and select Water. The next one is to add the electricity to compressor block B1 and B8. Go to B1 first. In the Setup form, please go to Utility tab. Select the utility ID as Elect, as well as block B8. Go to Utility tab and then select the utility ID as Elect. After that, click Run. You will see this window pop up. Seems like there is some error, so click OK. There are some warnings in B5, so please click B5 here. In the Status tab, it will show the error here. The first warning showed about the minimum approach temperature violated in utility water in the heater block B5. Seems like the minimum approach temperature that is already set as the default is quite high, and then the calculated minimum temperature approach was violated. The second warning is about the consistency problem with the utility water in the heater block B5. It said that block duty is negative, but the utility can only be used for heating. So these are the problems of the cooler that use the cooling water as the utilities. So think about how to get rid of these warnings. Let's go back to water input form. Since the water is cooling water, and it is the cooling utilities. So, in heating and cooling value, we should use the negative sign to represent the cooling energy. And we can also adjust the minimum approach temperature here. Since we have used the temperature units as Fahrenheit, so the value of the minimum temperature approach should be in the unit of Fahrenheit as well. So I will change here as Fahrenheit and put the value as 3 Fahrenheit. Then click Run again. Now, the flowsheet has converged successfully without any error. So, let's check the calculation results. For each block, for example, block B3, which is the heater, you can go to the result form of the block B3. Then go to the Utility Usage tab to see the utilities duty and the relevant cost. Here, there will be a utility duties required for the block and also the utility usage or the flow rate of the utilities, as well as the cost. You can also click the results form of each utility type, for example, elect, to see the summary of the duty supply for each block, as well as the cost and the CO2 emission rate for each block which that utility type supply for. You can also check the result summary folder, operating costs, and the utility cost summary tab to see the summary of the duty required, the mass flow rate of some utility types, and the relevant cost for all utilities. You can also perform the greenhouse gas emission calculation of the ammonia process and utilities by using the following data. Select the standard for global warming potential as US EPA 2009. Set the carbon tax for $50 per ton by putting in 2.5 cents per pound. And then specify the fuel types as natural gas for electricity utilities by using CO2 emission factor data source as US EPA Rule E95711. So, first of all, you need to go to the Setup folder, then the Calculation option and the Calculation sheet. Go to the Standard for Global Warming Potential field and then change to US EPA 2009. In the carbon fee/carbon tax, put $0.025 per pound. After that, go to the Utilities folder. In the Electricity utility types, click Input form. In the Carbon tracking sheet, select Calculate CO2 emissions. And then in the CO2 emission factor data source, select as US EPA Rule E95711 and the ultimate fuel source as natural gas. Then click Run the simulation. Now the results are available. You can go to check the result by going to Result Summary folder and then click CO2 emission form. In this sheet, in the hierarchy plant, you will see the net stream CO2 equivalent, which is the net CO2 equivalent emitted from the process streams. So you can see that it is very small, meaning that the CO2 is going in and out, which balances. The next one is the utility CO2 equivalent, which you can see that it is the main CO2 emission source. And this number is mainly from the electricity, which use the natural gas as the fuel to generate the electricity. and also the total CO2 equivalent, which is the summation between the net stream CO2 equivalent and the utility CO2 equivalent. And the last one is the net carbon fee or tax. Since we have inputted the carbon fee in the setup folder, this sheet will calculate the carbon fee or tax that the company needs to pay. The table below here shows the flow rate of the feed stream and also the product stream that can be converted to CO2 equivalent. And you can see that the CO2 equivalent in and out is almost the same.